Thank you everyone for joining. Today we're going to talk about orchestration and how we can repeatably use resources effectively, either between the ground on the cloud, or either in the ground or on the cloud, in the clouds. So John Mailhot's with me, my colleague, and I'm Gareth, Willis, a product manager from Imagine Communications. So I'm going to start by going back a little bit, and to understand where we're going, it's good to know where we've been. So in the 2010s, we started with SDI connected devices. Most of the time we shipped appliances. We had point-to-point signal chains, which mostly ran, as I said, on proprietary hardware. Skill set was video scopes, SDI tools, patch leads, and that was the age of the true broadcast engineer. Then John pioneered IP-based workflows.
Don't blame me.
Network media transport, and we started to move towards common off-the-shelf hardware. So your traditional broadcast engineer had to learn a little bit more about IP networking. They might have had to do a CCNA course, and then they started to learn about routing. So we made the migration from appliance-based hardware to software and those IP-based workflows. As we look today, we're fully COTS hardware. We're running on standard IT infrastructure, and we're migrating towards Linux and effectively more software-defined workflows. And so we're moving from static to more of a dynamic environment. So as we look to the future, we're going to see more hybrid workflows. We're going to see more cloud and on-prem workflows. We're going to see more software-defined applications. You're seeing the DMF and the MXL work that's being done in terms of splitting everything up into containers, orchestrating it in Kubernetes, and we're starting to hear terms like cloud native and DevOps. So we now are transferring from static, dynamic, and then moving from always on infrastructure to on-demand infrastructure.
Now, why would you want to do that?
So by splitting it up into smaller modules, we're able to share data more effectively. We're able to build workflows in a Kubernetes cluster. And also we're able to take advantage of some of the more common IT off-the-shelf tools that are cloud native and cloud enabled.
But why don't we just leave it on all the time?
So the problem with always on is that channels run 24/7 regardless of demand, right? So you had to build your facility for effectively 100% capacity or your peak capacity. If you wanted to change anything, there was manual configuration, it introduced risks, and it took time. So with always on infrastructure, you always had a high cost, a high entry point, and low flexibility. So it was built for certainty, not efficiency. And then the cloud came along and changed the rules. So the cloud obviously meant that you had to everything was billed per second, per minute. Obviously you had access to infinite resources and you could scale dynamically and the infrastructure could be created instantly. But from an operational perspective, this also added challenges, right? So you had to deploy quickly and it had to be correct every time. And you must have access to APIs and all of the workflow tools that you wanted. Effectively, you needed that instantly, right? If you didn't do it quickly or have it available correct every time, then you would incur a cost.
So I remember, 5-6 years ago now, we started deploying people's channels in the cloud, and we had a client that would every afternoon spin up a bunch of children's programming. So kids come home from school, magically there appears a bunch of channels. They ran them just until the news hour, and then about 6 p.m. they turned all off. They did this, I think, in Azure, actually. And then, so what was their experience on, how long before the moment they need them would they remember to, log in and click go?
Those channels, and this was in the very early days of cloud, those channels were provisioned and ready to go, and they were effectively actually running 24/7. So they didn't have the benefit of orchestration back then, and obviously that has a direct obvious cost because they couldn't deploy them quickly, and they had them running effectively 24/7. So they were incredibly inefficient to run.
Okay, so they didn't even park the VMs overnight?
No. So
So orchestration.
yeah. So orchestration solves this. So orchestration is the enabler. So what it enables us to be able to do is to have predictable deployments. So I can deploy my system first time, every time, and get the same results, right? And it also reduces operational risks. So you don't have to configure. You don't have to go into configuration tools and go click, 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 click. We try and script everything so that we reduce any configuration risk. And obviously a faster time to air. If we can deploy it quickly and we can deploy it right first time, then you're going to get to air faster. And that's going to improve your overall utilization and lower our customers' costs. So, and I say it simplifies operations, and I think there's a certain step that you've got to get up to. So there's a level of complexity to get into orchestration and to script your deployments and to get repeatable deployments. But once you've sort of turned that corner, then it does simplify the spin up of resources within a cloud-based environment or even on-prem. So orchestration really turns your infrastructure into repeatable, observable, automated deployments. And it helps you to reduce, or helps our customers to reduce the cost and inefficiency within the system.
Is the cloud required to get these benefits? Or if I had like on-prem compute or I had my own data center for some other crazy reason, can I deploy there?
Yep. There is tools for that. And obviously orchestration is built on an ecosystem. The cloud has its own tools. Obviously you have access to be able to spin up resources, dynamically, and you have access to infinite resources. But for example, if you had your own cluster internally, if you had your own, effectively VM cloud, you can use all of the tools, and we don't have to build these tools ourselves. Today, dynamic infrastructure is really a reality. So, for example, I can deploy virtual machines, or I could deploy AWS resources through Terraform. I could use CloudFormation as another example. There are many tools out there that you can deploy the infrastructure. And then I can configure using Ansible. So I can string together different commands and different command sets via Ansible workflow. So I could deploy a VM through Terraform, and then I could apply configuration within Ansible or within the orchestration tool. And then what we talk about with the DMF is really these runtime and scaling environments. And there we're talking about tools like Kubernetes, Nomad, OpenShift, and these container runtime environment variables, where I can kind of say, hey, look, I want 2 of these pods running all of the time. And if one of them fails, move it over to the other pod. So they dynamically be able to handle redundancy, so that we don't have to in part of it from the software side of things. And then obviously you need a way to observe, right? You need a way to get data from these systems, and you need a way to be able to look at that data and visualize that data. And there are tools that are common off-the-shelf common off-the-shelf tools like Prometheus and Grafana that enable that. So these are proven industry standard tools that are capable of managing either ground or cloud resources. But what I will say is the tools don't actually equal operations. There's another layer on top of it that we as broadcasters and as content providers need to provide.
Yeah. I mean, I've watched, many of our products deploy in Kubernetes already, and I watch our, technicians deploy these things, and they're typing Linux commands and stuff. And I'm just thinking there's an air gap between the skill it takes right now to deploy these things. Even when you have Ansible and Terraform and so forth, there's a pretty good air gap between that and the people who are currently operating television facilities. And we have to make some glue that closes that gap and operationalizes these systems.
Yeah, and that gets back to the, where we're going slide in terms of moving towards Kubernetes and moving towards DevOps. Those sorts of operational environments are orders of magnitude more complex than what we're dealing with and have been dealing with for the past couple of years. And that's what obviously the DMF is going to try and put some structure around in terms of bridging the gap between the tools that we have available in the IT world now and what the broadcasters need. And those are the missing pieces, right? So the tools that, and just to go through some of the tools that they don't provide, is automation and scheduling. What if I want,
for example, yeah.
What if I want to deploy this for a weekend? Or what if I have a tennis match that I want to do in one afternoon?
A clipboard and a pencil. Come on.
Yeah, exactly. Operational workflows, like how do I get a clip to the box, and you know your routing and how do I get signals to it? How do I manage that routing layer? If I split everything up into different components, how do they all talk to each other from a routing perspective?
Right, because when we developed SMPTE 2110, we get the signals onto a packet network, and I kept telling people, look, it's the first step of like a 17-step process, right? And yet there was a lot of disappointment in the industry that somehow getting the signals onto a packet network didn't like cause the moon and stars of every possible, beautiful thing that could happen next. And I feel a little bit like we're in the same zone with MXL right now, where it's an important piece. MXL is like a road for getting the packets, getting the video around. But without car and a map and a destination, you're going to be very disappointed in your vacation. So that's really this promise I see, is that, the DMF project above that has to really do some work to solve a problem that we've never solved as the industry in all the years I've been in the industry, which is describing the intent, describing the production intent, the production workflow in an organized, syntactic way that can then be used to drive its deployment. But it can't be a pencil and paper. It has to be like an organized object structure that really defines exactly what the requirements are of the production, so that then an automated deployment system can chew down that and allocate the pieces and make it go. And it's not like we have one of those off the shelf. That's work that's been waiting to be done in the industry kind of like forever. But this time, we're going to go do it.
And just to that point, the question you threw at me earlier about the kids programs that spun up every day at 3:00. I mean, the automation and scheduling part of that is exactly what is needed for those types of use cases. We ran the cloud resources ran effectively 24/7, but if we could spin them up at 3:00 and then turn them down at 7, then that is going to save a lot of money for customers.
Right, but that goes back to that orchestration equals repeatability thing. If the error endpoint is 30000, how much earlier? I guarantee on the first day they're going to start working on that at noon. But then a week later, it'll be 2:45 before they try it.
As they get more comfortable and as they refine their workflows. The other component is how you control the system, how you have a unified control layer. Especially if you're, with the DMF and the where MXL is heading, and with multiple vendors within that same ecosystem, how do you unify that control across systems? And then also, if you're running sort of playout in the cloud, then how do you synchronize that data? If you're running multiple sites, how do you synchronize playout data? How do you synchronize content metadata? So, the tools to automate the components are there, and they're off the shelf, and they come from the IT world. It's the workflow and control layer moving forward as we go into the DMF that's going to bring the big business value.
That's why the DMF is a set of working groups. So there's a working group on timing, there's a working group on connection management, there's a working group on compute resource description, which is an important one. And there's also a business process working group, which is really important. And we need more television customers, especially to join the business process working group, because ultimately all these things are driven by a potential economic benefit. But there's also cost, because to operate a facility of this complexity, a television operator has to have an engineering team that's adequate to the task. And it's a staffing issue. You have to actually staff and train and work toward being ready to have systems of this complexity. So there's a business benefit, but there needs to be planning and there needs to be budgeting, and because there is also cost.
So
what would you do with this if it worked?
So let's take a look at some use cases, or some common use cases that we're seeing coming up in terms of, if we can orchestrate and dynamically spin up these environments, what sort of use cases could we cover? So the obvious one is obviously pop-up channels, right? For sports events, for elections, for any special event, right? Even things like house of worship. events that could be spun up, and it allows the content creators to get their content out, and they can get it out in, a professional way with more integrated tools, right? So the idea would be to create a fully configured playout chain in hours, and then use it for the duration of the event and automatically decommission it when needed. But it also allows, 24/7 broadcasters to experiment. It allows them to get, an idea out there and fail fast. So it gives customers flexibility, is what it's going to do.
Yeah. And not all pop-ups are like, obviously pop-ups. There's a lot of times that you watch a thing, you don't realize that was a pop-up channel in this lingo. It's just you watched a tennis match and that's how it got to you.
Another obvious one is business continuity. So, being able to spin up infrastructure only when it's required. Automatically fail over to your DR when you need it. And there's no need to permanently run a DR system. 10 years ago, customers would actually have a full rack room running DR in a different building, paying for power, paying for, air conditioning. When nowadays they can just point an orchestrator tool at the cloud and say, spin me up 4 channels, and it could be done in 10 minutes. And they could, depending on your risk profile, they could be back on air in 10 minutes and not incur those costs.
Yep. And it can be spun up in a region that is not the region you live in.
Yeah.
Because otherwise the same disaster could happen twice, right?
And, this extends also out to being able to test and, as you're doing a software upgrade, for example, you could be spinning up a parallel environment to be running just in case something goes wrong. Obviously nothing is going to go wrong, but it gives you the ability to be able to do that. And then once you're done, you can decommission it.
Yep. There's also training value. We've seen customers use their spun up DR system as a way to train staff on how to, navigate and use systems, because you really don't want to train staff on the live system during the day. It's people watch.
And then we start to get into some interesting and more advanced workflows. So, we've called it redundancy by risk tolerance, but it's effectively context-aware redundancy, right? So if I'm running a cloud channel, I don't need to run an A and a B instance overnight if all I'm doing is playing reruns and freebie content. So I can scale back my redundancy, reduce my utilization, and reduce my cloud costs. And then if I have a high-profile sports event, I can bring up additional resources, A, B, and C, to cover that event, and then I can bring on resources appropriate during prime time. So it allows us to be able to obviously reduce that. It optimizes your utilization, reduces your cost, but it also has another benefit, and that's able to tell a better sustainability story, right? Because if you're optimizing your resource, you're using less power, and generally it's better for the environment. Then the other one is dynamic regions. So think about it as the orchestrator initiates a channel, and that could be in the cloud, and the orchestrator is aware of the channel content, the schedule content, and it automatically links to, let's say, a main market, and will spin up when required for regional breaks. I know customers often, have resource sitting in a rack, 4 channels for 4 regions that they may not use for days, but they need it there, and that's that always on infrastructure, having to provision for the worst case. Right. If you need 6 regions, you can spin up 6 regions. If you need none, you don't need that resource.
Yeah. If you think about a national network, very often the content is the same nationwide. And really it's only during certain news breaks and other times that you need the regionalization and sometimes localization. So if you can run the main channel all the time and only spin up equipment for those regions and locals when you need it, there's got to be a significant cost savings there.
Yeah, so we can, we can scale the resourcing by the audience and advertising demand. Sometimes it actually costs more to have someone fill up a whole market full of freebie commercials. And so being able to just spin it up when required is going to help customers optimize those running costs.
Well, so, what did we just say, right? So sometimes, historically, like if you walked into, say, CBS 15 years ago, you would ask the question, what's the worst case number of college basketball games that can happen on one Saturday in the springtime? And the answer was 17. And so there were 17 network chains because of college basketball in the springtime. There was no other point in the year when all of those chains would be in use, but there was one day when they would be. So that drove the design of the whole facility. Can we do better today with these technologies? Absolutely.
Always on still has its place, but when we design these systems, we shouldn't actually assume that it's always going to be the default. We should use cloud where it makes sense. And we did the numbers and we said that it was around less than 30% utilization. It made sense to run it in the cloud. Over 30%, it made sense to run it on-prem. So, cloud does make inefficiency visible and it's a chargeable expense and you'll get a bill for it. So orchestration is what is going to enable us to drive these on-demand workflows, to be able to turn systems on and off and be able to get some of these more complex workflows in terms of those regionalization and resource optimized disaster recovery workflows.
Yep. So it's all about scaling what you're doing to match what you actually can sell.
Yeah. So orchestration, the DMF, the MXL, as we move forward, orchestration is really going to turn infrastructure and give our customers business agility.
Well, that's what they thought they were getting all along, right? Now it's time. So, any questions? Thank you for joining. I know half of you, but somebody's got to have a question. Gareth, you're always good for a question.
Bob, I have a question for you, John. You mentioned something that's quite dear to my heart, which is the declarative model to describe a system. So how do you envision that? Something like I would be able to say, I want to set up this small facility with 4 cameras, a vision mixer, a bunch of microphones, etc., and then just render this as compute and deploy it and start it up.
I think it's something like that. Yes. I mean, imagine a JSON document that has a proper schema that really defines not just I need a switcher, but I need a switcher with 4 inputs and 2 MEs and this video format, and like enough detail that you could go out and buy equipment to do it, right? That's roughly the level of detail you need to also provision it, because then you can match those items against things you have in inventory and capability you have in inventory as well, and spin up pick the right ones, spin them up, connect them up. You need to capture the production workflow in an organized, syntactically clear way. And there may be things like that. Michael Zorn pointed me at one from Movie Labs that sort of attacked this for the, some part of movie workflow. It may be something that we have to, make a working group and create. But that, in the 211020, we went through an exercise of how do you describe the pixels you're getting? And we came up with a syntax that I think will outlive 2110, honestly. And I think the same thing is one of the missing links here. How do we describe a production workflow or a playout workflow, or, in terms of the inventory of parts and how they're connected and, how they link to playlists and asset bases and real world things, because that's all the data you need to deploy it. Right, sir?
So for orchestration to be effective, you need a good source of truth or inventory system to know what to orchestrate with a good flexible data schema to work with the various different platforms that are around here. What are people in this industry using? I haven't really.
Well, what are we using right now?
Haven't really come across anything in the last.
Clipboards and pencils.
Okay.
Even trying to get the television industry to use DHCP to assign addresses has been a miserable failure.
Or DNS.
Or DNS. Oh, God forbid. We have a product that requires DNS to be working in a facility, and you'd be shocked to learn how many places we go into that, forget about it, right? We have to bring our own. So it is a climb, right? You have to have a basic IT infrastructure that works and a bunch of things. There's a fair bit of motion toward Netbox as a source of truth, but that's sort of like a default answer for everybody who uses Netbox as a source of truth. There's other people who use it as a sink of truth, and other people use it as an ignorable third party. And that's just as Netbox is free. So you're right on the problem. It's solvable, but not yet. There's not a common approach, and there's a lot of clipboards and pencils. Spreadsheets. Right. Anybody else? We yield the stage to Mr. Gunkel.